Hello dear friends, very good morning to all of you. Welcome back to the video lecture series. So friends, we are discussing the food analysis part and our current topic is protein analysis. We have discussed a lot of methods for the estimation of protein present in the food sample. Today we are going to see the last method for the estimation of protein in the given food sample, and the title is UV, that is ultraviolet 280 nanometer method. UV 280 nanometer method. This is the last method. I think it is number 8 or 9. Okay, and this title is indicating that this method is depends on, or it is based on, the absorption of ultraviolet light by the proteins component present in the food sample. Okay, we know that all these proteins are made up of building blocks units known as amino acids. So amino acids some amino acids contains aromatic side chains such as tryptophan and tyrosine. Okay, so these aromatic side chains are responsible for the absorption of ultraviolet light, that is UV light, from the electromagnetic radiation, and this is the main principle behind the use of this method for the estimation of proteins in the food sample. Okay, so that's why the principle lies here. It is based on the UV absorption at 280 nanometer. Okay, so most of the proteins which are having aromatic side chains, generally tryptophan and tyrosine, they absorb the UV light at this wavelength, that is 280 nanometer. So hence the name of the title, hence the name of the method is UV 280 nanometer method. Okay, hence the proteins show strong absorption. Mainly proteins show strong absorption, that is lambda max. Okay, at 280 nanometer, mainly due to tryptophan and tyrosine residues present in the proteins. Okay, and hence this is utilized for the estimation of protein content, estimation of protein concentration in the food sample by using Lambert-Beer's law, or simply Beer's law. We know that Beer's law is nothing but the absorption of any species is directly proportional to the path length and the concentration. So path length here is considered for the cuvette cell, or the length of, or the breadth of the cuvette, okay, or the sample holder, let us say. We know that the principle and theory behind this Lambert-Beer's law, we already studied it. Okay, so the basic theory behind this UV absorption is based on the Lambert-Beer's law. Okay, and Lambert-Beer's law is nothing but absorbance is directly proportional to B into C, that is B is breadth, that is the path length of cuvette or sample holder, and C is the concentration of proteins. Okay, now the procedure. So the procedure of this UV method is very simple. Just dissolve your protein sample, means your food sample, for which we have to determine the protein content of the food, in alkali or buffer solution. Okay, we have to dissolve that protein sample into alkali or buffer solution. Alkali means aqueous base such as NaOH, KOH, sodium carbonate, sodium bicarbonate, etc. Okay, then once the solution is ready, then measure the absorbance of this alkali or buffer solution containing proteins at 280 nanometer. So 280 nanometer is the lambda max. At this lambda max value, we have to measure the absorbance of the given protein sample. Okay, and the absorbance of that protein sample is noted. Then the concentration or the estimation of protein is calculated for that given food sample or protein sample by using a formula absorbance is equal to A into B into C, where capital A is the absorbance, small a is the absorptivity, small b is the path length, and C is the concentration. Okay, concentration of the protein in this case. Okay, so by using this formula we can calculate the concentration of the protein. We are measuring the absorbance from the experiment, from the UV visible spectrophotometer. Then A is fixed, that is A is constant, that is known as absorptivity. B is path length, that is can be calculated by using that cuvette parameters. Okay, and C, we have to determine this C, and this concentration of this protein can be calculated by using this relation. Okay, now the application. So procedure is very simple. It is a one step process. Just dissolve your sample in a buffer or alkali solution, measure the absorbance, note down it, and use the equation for the determination of concentration. Now the procedure is application for this UV method is, this method is generally used for the estimation of proteins from milk samples, milk and milk products, as well as meat products. So meat products, protein content of the meat products can also be determined by using this UV ultraviolet 280 nanometer method. Okay, so mainly it is used for the milk and meat products. Now the advantages. What are the advantages of this method? So the main advantage is this method is very rapid. As per the procedure, you can imagine or you can judge that no other any sample preparation is needed for this UV method. Just you have to dissolve it in the buffer or alkali solution. So that's why, and you are getting the results in very short period of time. So that's why this method is a rapid one. It is sensitive. Then no interference of ammonium sulfate salts and other buffer salts. The buffer salts and ammonium sulfate salts are not interfering the absorbance of proteins, and hence this method is useful. Then this method is non-destructive. Non-destructive in the sense, we already studied the Geldal method and Dumas method. In both of these methods we are utilizing that sample, protein sample, and we are converting that protein sample into other forms of nitrogen. So that's why that method are destructive ones, but this UV method is non-destructive. So the sample is non-degraded. Sample is not degraded in this case. So that's why this is the non-destructive method, and hence we can use that sample, we can recover that sample by doing some analytical steps. But this method is also suffering from some disadvantages, such as most of the nucleic acids that are present in the DNA and RNA are absorbing at the same 280 nanometer lambda max. That is, lambda max is same for the most of the nucleic acids present in the our system or food systems. Okay, that is, they can also interfere in the concentration or the absorbance value of that food sample. Okay, so that's why it may give wrong results for the analysis. Then the next is solution must be clear. As we are using spectrophotometer here for the determination of protein by focusing the UV light on that sample holder, so that's why any impurities present in the sample may change the concentration or may change the absorbance value. Hence in this case the solution must be clear. Then again the reason is same here, pure system is required for this absorbance spectrophotometry determination. We require particularly a pure system. Okay, pure system in the sense The food sample must be pure. If there any impurity is present, then it may interfere your results. Okay, so this is all about our last method, that is known as UV 280 nanometer method. Okay, so in this way we have completed all the methods for the protein estimation. Now come to the last point of this first section of this chapter, that is analysis of proteins. Analysis of proteins is again divided into two parts as per our syllabus. The A section is consisting of protein analysis and section B is consisting of characterization of proteins. Okay, so this is the last part of this last topic of the first part, that is protein analysis, and from the next lecture onwards we are going to start the characterization of proteins. Okay, so this is the half part of this chapter. So comparison of methods is given in your syllabus. So comparison of methods means we have to do a comparative study for all the methods given for the protein analysis. We have studied number of methods for this protein analysis, known as Geldahl method, then Dumas combustion method, then Biuret method, then Lowry method, then Bradford method, then BCA method, and this one is UV method. Okay, so this topic is related to the comparison of methods. Okay, sample preparation. First topic is sample preparation. The sample preparation, we know that the Geldahl method, Dumas method and IR method require some sample preparation. A little sample preparation is required for these three methods, but the remaining methods does not require much more sample preparation. Okay, then principle. From the principle point of view, the Geldahl and Dumas method are estimating the total nitrogen content. They are estimating the total nitrogen content, and then we have to correlate that total nitrogen content with the total protein content present in the sample. Okay, but we know that as Dumas method is combustion method, and hence this Dumas method is giving the results related to the proteinous and non-proteinous part of the food sample. Means we are converting that converting the nitrogen content of that food sample into organic into dinitrogen along with the nitrates and nitrites. Okay, mind well. So that's why this Dumas method is giving the somewhat larger value as compared to Geldahl, Lowry, BCA, etc. Okay, then next point is sensitivity. So sensitivity, related to sensitivity, the first three methods, that is Geldahl, Dumas and Biuret methods, these three methods are less sensitive than the Lowry, Bradford, BCA and UV methods. Okay, so these three methods are less sensitive than the latter one. Okay, so Lowry, Bradford, BCA and UV methods are more sensitive methods. Okay, and the last point is speed. The speed as far as the speed is concerned, the methods which are related to the instrumental part, they are rapid. Okay, means IR method, UV method and one more method is there, that are using spectrophotometers. Okay, and such methods are rapid one, they are giving fast results, less time consuming. Okay, time saving we can say that, and hence, but among all these methods, the IR method, that is infrared method, is very rapid one. Okay, we are getting the results within a short period of time. Hence, from the comparison point of view, the IR method is very rapid, and Geldahl and Dumas method, they are time consuming, they are require much more time, 3 to 4 hours are required for the estimation of protein for Geldahl and Dumas method, because they require more steps are given for that Geldal and Dumas method. Okay, so this is the comparative part. Okay, this is only for the your sake of convenience. Okay, so in this way we have completed this first part of this 6th chapter, that is analysis of proteins, and the remaining half section of this chapter is related to the characterization of proteins. Characterization of proteins. Characterization of proteins. Okay, so in this method we have seen what are proteins, what are the different types of proteins, then simple general introduction, and then we have started directly the methods for estimation of proteins. Okay, including Geldal, Dumas, nitrogen combustion method, then Lowry method, IR method, biuret method, then BCA method, UV method, etc. Okay, so number of methods we have studied. Okay, so I think this is sufficient for this protein analysis. Okay, in next lecture onwards we are going to start the characterization of proteins. Okay, thank you very much. Thanks a lot for watching this video. Have a nice day.